Hello, we're from Pair 4. I'm Zahra and my partner Zarhana. We'll be presenting an article called Network Traffic Behavioral Analytics for Detection of DDoS Attacks. So this 2018 study addresses the increase in DDoS attacks on network-dependent corporations from 2016 to 2018, which has caused financial damages. The objectives of the research is to firstly address the increase in DDoS attacks, to use machine learning or ML to analyze anomalies in network patterns to detect possible DDoS attacks, and lastly to determine which ML model most effectively detects those attacks using the suitable matrix, which will be talked about right after this. For methodology in terms of diagnostic analytics, this research uses discovery analysis, which includes data preparation, modeling, visualization, and analysis. Data modeling and analysis is included in the quantitative approach part of this research. There are 6 ML algorithms used for comparison and also to find which ML model works best. We have multinomial logistic regression, k-nearest neighbor, random forest, naive Bayes, multi-layer perceptron, and lastly dense neural network. So there are 3 notable evaluation metrics. Firstly, we have accuracy, false negatives, because a high rate of it might raise a false sense of security and potentially dangerous situations may be missed. And lastly, time taken to train and run algorithms, because previous studies referenced in this article had much more longer training times. And data used. So the data used is from the intrusion detection evaluation data set generated by the Canadian Institute of Cybersecurity in 2017. So this dataset contains normal network flows as well as flows with DDoS attacks. And on the right here, we can see that there are 14 features. So upon EDA, out of 85 features, 14 have been selected to be used for this research. Now we move on to significant findings.
To find out the best models, the research carried out three evaluations. The first one is false negative rate is to measure the probability the model will predict to negative. From the table, we can say that random forest model performs the best with the lowest average false negative rate of 6.86. The second evaluations are the model performance. The finding shows that overall accuracy, precision, and training times are different across the models, with random forest leading in accuracy and precision. The next evaluations are the ROC curve. The ROC curve is to evaluate how well a model can separate classes. The closer the ROC value to 1, the better the model. We compare the ROC between dense neural network and random forest because both of these models have high prediction accuracy. By comparing them, we can say that random forest model performs the best in classifying most anomalies. In conclusion, the finding shows that random forest model outperforms the other five models. Next, let's discuss the limitation. Most of the public data sets are outdated. This does not reflect well on the current DDoS attack methods. And due to the privacy law like WIH2001, it restricts the access to network traffic and storage data. Organizations prefer releasing synthetic data from research lab to protect privacy law. And for future work, the model can apply in actual network and act as the detection engine to detect early attack. Not only that, it can also use as model alarm to network administrator when the anomaly is detected. For application of findings in real world, these findings has widely used to secure cloud environment. For example, AWS Shield use machine learning to protect their cloud. Next, tools like SolarWinds provide network monitor solution to monitor any such special activities and anomalies, and Cloudflare offers DDoS and protection service to mitigate DDoS attacks on clients' work. We have come to the end of our presentation. Thank you for listening.